All right, in this video, we're going to look at a couple examples of how we might encounter continuity inside of a calculus problem. So this first one, we have a piecewise function. It says, let f of x be this piecewise function. And notice there's three functions for this: x squared, square root of x, 4 minus x squared, and the bottom one is x minus 3. You should know how to graph all of these without a calculator. Hopefully you can just look and recognize what type of a function each of these is. If not, let's just run through it real quick. X squared is quadratic. This shape would be a parabola. That would be centered at 0. Sorry, centered at the origin. Let's skip the middle one and go to the last one. The last one is just linear. This is of the form y equals mx plus b. So that's a linear function. So the middle one might be a little bit tricky for you to recognize. A form that you would recognize clearer is x squared plus y squared equals 4. And you might recognize that as being the equation of a circle centered at the origin with a radius of 2. Well, look what happens if I solve for y. If I solve for y, I would have y squared equals 4 minus x squared. And then if I take the square root of both sides, I would have y is equal to plus or minus the square root of 4 minus x squared. So notice this is just in the piecewise function, we only have the positive square root. We don't have the negative square root. So the positive square root draws the circle above the x-axis, and the negative square root draws the circle below it. So we only have the positive square root, so we're just going to draw our piece of the circle above the x-axis. So this thing right here is a circle with the radius of 2, centered at the origin. Okay, so you might remember me talking about breakpoints. So this piecewise function actually has two different breakpoints. There's a breakpoint, I'm just going to call that BP, at x equals 0, but then there's also a breakpoint at x equals 2. That's just because we see zeros here and here. So there's one breakpoint, and then we see 2's here and here. So there's your second breakpoint. If you have breakpoints in your function, it's good just to figure out what those values are. So that's something you can do pretty quickly. So I'm just going to plug in my x value into all of these functions where it's defined at the breakpoint. So for the first one, the breakpoint is at 0, so x is less than 0. So if I plug in 0 into that, I would get 0, and then 0 squared is equal to 0, so my y value would be 0. So at the breakpoint, this has the coordinate 0, 0. Also realize that since this is strictly less than 0, it doesn't have the equal to part. This would be like an open circle. That does not look like an open circle. This would be like an open circle. So you're not actually equal to the x value. You're getting really close to it. So on the graph, we would put an open circle at that point. Now for our next line, we actually have two breakpoints. This breaks at 0 and also breaks at 2. So I'm going to plug each of those in. If I plug in 0, I would have 4 minus 0 squared, which is the square root of that. So the square root of 4 minus 0 squared is 2. So that would have the coordinate 0, 2. And that includes the equal to part. So that would be a closed circle at that coordinate. Then if I plug in the 2, x equals 2, I would have 4 minus 2 squared inside the square root, so that would be 0. And that does not have the equal to part next to the 2, so that would be an open circle. And then finally, we have the linear function x minus 3. That only has the breakpoint at 2. So if I plug in 2 into that, I would have 2 minus 3, which is negative 1. And that is equal at 2, so that would be for a closed circle. So now we want to draw a complete graph by hand. So this is not something you would be asked to do on the AP exam, but it really will help you out with calculus if you're able to draw these things by hand. So our first function here is the x squared. So let's think about what an x squared looks like. That's a parabola centered at the origin. So it would look like that. However, we don't need the entire graph of this. Piecewise function here says x squared is only defined for whenever x is less than 0. And we know that we have the coordinate 0, 0 where that graph should stop. So what I'm going to do is I'm going to delete this, erase this. And so I'm going to put my open circle in the origin that I figured out earlier, and then I'm only drawing my parabola to the left of that. So that would be the piece for the parabola, that first function, whenever x is less than 0. So my next function is the piece of the circle. This is only between 0 and 2. So if I have a circle with a radius of 2, well, radius of 2 would do something like this. It's just a quarter of a circle. And I'm making sure to put the closed circle at 0, 2 and the open circle at 2, 0. And then my final piece is a linear function, x minus 3. So the y-intercept for that is -3. If I drew the y-intercept, it would be down here at -3. And then the slope is equal to 1. So it goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So I only need the points for this whenever x is greater than 2. And I know that the value of the closed circle is at 2, -1. So 2, -1 is right here. And then I'm just going up 1 over 1 from there. So that is what my piecewise function looks like. And we can see by looking at this that this thing is not continuous. So for part B here, is f continuous? And if it's not, explain. So obviously it's not continuous. By the way, if you want to know if a function is continuous just by looking at it, think, can you draw the entire graph from left to right without picking up your pencil? So if I'm drawing from left to right here, in order to get to the next piece, I've got to pick up my pencil to go up. So if you have to pick up your pencil anywhere, then it's not continuous. Keeping in mind that anytime you see an open circle, you'd have to pick up your pencil just to skip over the open circle. So this is not continuous, and that is because we have a jump discontinuity. At x equals 0 and at x is equal to 2. Okay, second example. What value should be assigned to the value of a to make the function continuous at x equals 4? And so our function here, we have a piecewise function. The top function is defined whenever x is less than 4. That's a linear function there. Bottom function is defined whenever x is greater than or equal to 4. That's also linear. A is just some number. So we want this thing to be continuous. And we have to find the value of a that'll make that so. So what we need to do is we just need to start treating this thing as being continuous. And how would we show that it's continuous? Well, we would look at the left-hand limit, the right-hand limit, and the function value at c itself. And then if all three of those are the same, then it is continuous. So that's going to guide us on how to show or find the value of a to make this continuous. So I'm going to start off by finding the left-hand limit. So this is going to be approaching x equals 4. And if I'm on the left side of 4, then I'm using the top function, 3x minus 4. So I'm going to do 3 times 4 minus 4 would be 12 minus 4, and that's 8. So my left-hand limit for that is 8. Let's find the right-hand limit. The right-hand limit would be I don't know what a is, so that would just be a times 4 plus 1. And I don't actually know what that's equal to. But remember, we're trying to choose a to make this thing continuous. And then we need to figure out what's the function value of 4 itself. This is actually going to be the same as our last thing. Whenever it's equal to 4, you're just using the second equation. So this would be a times 4 plus 1. And then in order for this to be continuous, we have to say, well, the left-hand limit, which was 8, has to be equal to the right-hand limit, which is 4a plus 1. And that has to be equal to the function value at 4, which is also 4a plus 1. So I'm not going to write the second 4a plus 1. So that gives us this equation right here. In order for it to be continuous, this has to be true. 8 has to be equal to 4a plus 1. So now I can solve for a. I've got a single function, single equation that involves a. I can solve that and find the value of a that would make this continuous. So I'm just going to subtract 1 from both sides. That would be 7 is equal to 4a. And then I'll divide both sides by 4. So then that would give me a is equal to 7/4. And that is the value of a that makes this true.